Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Miličić and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. Specifically today, we will try and tell you a bit about the server utilization crisis, a modern paradigm that has an increasing impact on operational costs and energy consumption. We regularly hear from people running very large clusters, often numbering nodes in their thousands, and where server utilization is typically between a staggering 6 to 12%. And when a problem appears, companies tend to throw more servers at it, rather than increasing utilization of their existing capabilities. So all this leads to increasing operational costs, increasing power consumption and associated energy costs, and finally, increasing costs of creating and running large facilities. The discussion that you are about to take part in will present an alternative route, one where server utilization can be dramatically enhanced, leading to significant savings and less complexity in operations management. Now, as with any live event, please excuse any technical issues that we may face today, but to start by telling you a bit about Erlang Solutions. We are a products and services orientated company completely devoted to the Erlang programming language. Since our start in 1999, we have worked with organizations and individuals using Erlang, helping evolve the language and supporting people and businesses using it. Today we are just over 100 people across our offices in London, Stockholm, Krakow, Budapest, Seattle and Buenos Aires, and working on projects across the globe. We are very keen on creating value and competitive advantage for our customers across industries and through the unique features and characteristics of Erlang as a language. Specifically, we develop Erlang-based products, and some of those include our Mongoose IM messaging platform, the React distributed data store, and Wombat OAM, which is a monitoring and management technology, as well as many other solutions applicable across sectors and problem areas where Erlang makes sense. I'm really pleased to say that our speaker today is Kenneth Tan, the CTO of Sardina Systems. Kenneth has spent many years leading the technical development of companies across industries and helping businesses and individuals benefit from improved utilization of their existing capabilities. In today's talk, Kenneth will try and give us a tour of the technology Sardina Systems provide to help companies substantially enhance their server utilization whilst decreasing the operational costs and energy consumption. Now, please allow me to finish by saying you are welcome to post questions throughout the duration of the webinar. For that purpose, you can use the chat facility on the webinar's interface. Our speaker, Kenneth, will answer as many questions as time allows at the end of the webinar. If any questions do go unanswered, you're welcome to raise them by email using the following address, webinar@erlang-solutions.com. If you're interested in learning more about Sardina Systems' products in general, or wish to establish whether they could be a solution for the challenges your own business may be facing, then please feel free to contact me directly. My email address will be displayed in one of the final slides of the presentation we will share with you today. The same goes for any other questions you may have. Feel free to contact us. I would now like to hand over to Kenneth Tan, who will be glad to start us off.
Thank you, Mladen. Good afternoon. My name is Kenneth Tan from Sardina Systems. I lead the technical solutions operations at Sardina Systems. We are a cloud data center infrastructure ISV headquartered in Tallinn in Estonia. We are focused on the infrastructure as a service data center segment. We have developed the world's first energy saving and utilization improving solution for OpenStack. We believe that by addressing the energy saving aspect, we can massively decrease the other costs amongst the top 3 cost items in data center operations. We've been selected by a large site recently for managing a 150,000 VMs operation in production. The software we can integrate quite easily with Red Hat OpenStack and SUSE Cloud, and we can look at this a little more later. The team behind this, as always, software is built by teams. We have a team that has been working with OpenStack since the early days of OpenStack, with now nearly 4+ years of experience. The senior team all came from large-scale data center operations and in developing software to target such environments. We're now partnering with Erlang Solutions to bring FishDirector to customers operating large-scale facilities, and this combines Erlang Solutions' commercial strengths with our technology and our know-how in scalable data center operations. With this, customers can rely on Erlang Solutions' outstanding service, now backed by Sardina Systems in data center operations and automation. In conversation with clients, we typically find that clients who are tasked to solve data center bottleneck problems, having to decide on complex workload placements, struggling to keep data center balanced, and constantly tuning and refining to try to cope with server utilization problems. Overall, this tends to lead to quality of HR utilization being relatively low, and OpEx and CapEx being unnecessarily high. Does this sound familiar to you? Conversely, by having an automation system which automates workload placements, prevents bottleneck, keeping data center well balanced, and hardware utilization optimal, one can not only increase HR utilization to be higher quality and more effective, we can also optimize OpEx and CapEx within the data center. What we do is to bring you from the state of constant worry to Zen. Now, we know that the top 3 cost items in data center operations are hardware acquisition cost, energy, and facilities. But ultimately, it's about what you do with what you have. Perhaps we should look at what is done with the resources. First, reservation is about what is requested. Utilization is what's actually used. As observed at some of the large sites, reservation could be up to 80%, which is high, but utilization remains consistently low at sub 20%. This underutilization of servers then leads to unnecessarily requiring more servers to cater to the workload, to the same workload, more energy to operate and cool more servers, and larger facilities which cost more to operate to house the extra servers. as we see, utilization at some of the operators could be in a 7 to 15% range. Would you think of leaving lights on at home for the whole week while being home for a day? That, by the way, is less than 15% utilization. The solution to this problem from Sardina Systems is our product FishDirector. We have an analytics-enabled core for fast initial right placement of workload driven by live resource utilization. And then as the workload changes within the facility, we dynamically reallocate the workload across the entire facility. With this, we then drive down energy costs by much better utilizing the servers, which then means that the workload could be catered with less servers, lower servers translating to lower number of servers translating to lower CapEx and lower OpEx. With less servers, you then need a smaller footprint, smaller facility footprint to house the servers. Uniquely, we can do this without requiring data center partitioning. And we can also scale to span multiple sites. And it's a solution which is workload application independent. Now, business is quite simple. If you have lower costs, it leads to high profits. We can enable this with optimal high-density VMs packing using FishDirector. How much can you really save? Well, if you look at a 55,000 server facility running at circa 15% utilization, the yearly energy bill at 10 cents per kilowatt hour will come to approximately $50 million. By raising utilization to just 45%, which is by no means the top, we could save in the order of $10 million a year in energy. And we've seen this type of multiples before. On the CapEx side, again, with a 55,000 facility catering to workload growing at 16% a year, also running at 50% utilization across the facility, using models from a large operator, which spent in the order of $1 billion over 4 years in hardware infrastructure CapEx. By raising utilization to 45%, one would be able to save in the order of $600 million in hardware infrastructure CapEx. It's quite simple. Raise utilization, you could do with less number of servers. How do we do it? The software has a number of very interesting parts. ultimately, to drive decision making, one needs to collect data. We've built a super scalable state data collector, which then siphons data into a scalable data warehouse. And then on the other end, we siphon data back out to drive our decision engines. Every single part of the software has been designed to scale and to be reliable. So we could, where necessary, add additional components to cater to the workload without interrupting the other parts of the software. And by doing this, we can also cater to higher resilience. We can do this integrating into existing OpenStack, masking away a lot of the underlying complexities. So how do we drive decision that's completely transparent to the end user being the data center operator? Doesn't need to worry about that. As we see here, we have a component here for optimization, which is integrated as a plugin to OpenStack Horizon, which is the OpenStack user interface. There are a number of use cases that I can take you through. One, it's the disaster recovery use case. Now, it's quite common in some large commercial organizations to have DR environments which replicate either partially or fully the production environment in one or more locations. This is quite costly because it multiplies the CapEx and OpEx. The servers typically sit idle under normal conditions, waiting for disaster to happen, really. And then when disaster happens, you need special situation work processes, which are error-prone and they're very intense on training. With FishDirector, what we can do is to have workload contained in VMs running on physical servers spanning the multiple locations. And then in the event of disaster, we then flow the workload over to whichever one of the sites that is up and running. And this flowing of the workload could be done automatically. With this, you have no over-engineering, so you don't have idle resources, and there's no hardware that's sitting there waiting for disaster to happen. And the whole process could be done just using normal work processes. So you remove training out of it. DR test, very simple. In the event of disaster, response could be in the range of minutes. What about market disaster? Now, today, some organizations having to cater to market disaster situations would again over-engineer to try to handle the demand spike. And when disaster happens, the response is typically in the range of hours. Again, similar to the DR situation, you're also relying on special situation work processes, which are again error-prone and intent on training. With FishDirector, what we can do is to dynamically manage down the workload designated to be low priority. So, for example, in the event of a market disaster, you may want to allocate your compute resources to risk. At that point, you don't care about compliance department's workload. So what you could do is to then manage down the workload of the compliance department, thereby freeing up resources to make it available for risk. All this is based on an existing set of resources. So we're not talking about adding hardware here. So at every point in time, you have no over-engineering, just relying on optimal utilization of resources. Again, no training required. And when it comes to disaster handling, it's very easy to do. Response to market disasters, again, measured in minutes, not hours. What about test and development? We often hear about test and development to be smaller than real production scale, and developers may not be able to test scalability. Resources become underutilized and are often idle. It's a cost very, very expensive wastage, to have servers sitting doing nothing. And when developers want to test certain capabilities, it's also very slow to respond to that requirement, which then means HR utilization is suboptimal. Then and after all that, to take the software from development into production, you again have to craft work processes which are error-prone, intensive on training. Now, conversely, with FishDirector, what we could do is to provision like-for-like scale. And we just manage resource allocation in the back end. With this, you can seamlessly go from development, test, into production. And this can be done with zero training required. Response to developers' requirements, seconds. What we want to do is to take you from the worry, suboptimal, inefficient state into state of Zen. What's the resources required to run our software? It's actually quite minimal. As you see on this slide, memory, CPU requirements, it's negligible by today's standards. To be operational, we recommend 4 physicals, to have full resilience, which is what we recommend if you are running tens of thousands of servers. It requires 20 plus servers, basically to cater for each and every single part of the software to have a failover component. And that's it. Let's try to increase your data center efficiency with FishDirector. Thank you. Laden?
Kenneth, thank you for the talk, and I'm sure everyone else being present at the webinar will join me in thanking you for a very inspiring sort of detailed insight into the server utilization crisis and obviously Sardina's response to that. So Kenneth, I can't say this very often, but to me this was particularly interesting as the use case and the solution that you presented are crystal clear in terms of how the technology sort of acts against server utilization and its sort of outcome on cost and savings and simply increasing profits where obviously costs previously stood. So just to try and best use the time that we still have available, we've received a number of questions as you were speaking. So to try and honor as many of those questions as we can. One of the questions is just focusing on scalability, and one of our audience is asking, where does FishDirector max out in terms of scalability? So meaning, how far can you actually go in terms of numbers of nodes, virtual machines, and so on?
Okay, let me try to break that question down into several parts, just so that the audience could try to understand how we approach the problem. To scale in such an environment, given that we build on top of OpenStack, we don't build inside OpenStack. So OpenStack is a tool for us. We collect data outside OpenStack. We make decisions outside OpenStack. Post decision making, we then instruct OpenStack to execute the actions necessary. So then let's look at the data collection and decision making aspect. On the data collection side, we have a data collection system which on each node collects the data and subsequently streams the data in to a time series database. The data collector on host is quite standard. This is based on collectd. But the IP is in how do we stream data from that node into time series database. And there we have certain technology which implements the concept whereby you stream data to a destination. You don't care about the target. At that destination, you could deploy n number of targets as necessary. In a fashion that's not too dissimilar from, say, when you're writing a letter to electricity company, for example. You send a letter to electricity company, you don't care about who actually opens the letter on the other end. And on the other side of the data warehouse, we then siphon data back out to make decisions. That decision engine can be, that part, we can operate it with multiple copies of the decision engine to, again, to cater to the workload as necessary. So that way, as a facility scales up, it's a simple matter of deploying more copies. Now, if I want to put a figure to where do we scale to, our design criteria is 100,000 physicals. Okay, so I hope that answers the question.
I think it does. Thank you, Kenneth, for a detailed answer. Now, we have another member of the audience, obviously coming from a larger sort of organizational background, and effectively asking, how complex is implementation of FishDirector in terms of multiple data sites? So we're talking about, 5, 6 data centers, scattered across the globe.
Okay, so the complexity, again, let's break that question of complexity down to several parts. So first off, let's assume that the facilities are able to see each other on a network level, and you have a control plane that is able to access cross sites. Once you have that, with the FishDirector components deployed at multiple sites, recall that each one of them can have multiple copies across multiple sites. Then, in the event of disaster, or in the event where you want to flow workload from one site to another, this could be all managed as if it is one large facility. It becomes transparent that way. Okay.
Thank you, Kenneth. I think, again, that sort of gives us a good answer. Now, one other question that, and questions keep arriving, so again, apologies to everyone, as we won't be able to cover all of them, but Gokhan is asking, how complex is the integration process with FishDirector? And do you need to run, an Erlang virtual machine on the nodes where you're implementing FishDirector?
So the short answer is no, we don't. So perhaps I can elaborate further on that. Now, on each of the compute nodes where you actually run VMs, what we deploy there, in addition to standard OpenStack parts, is a data collector. So to get us the necessary metrics. And then the data warehouse parts that will be deployed on a separate machine or separate sets of machines. And similarly, the decision engines. Perhaps let me go back to this slide here, just for reference. And then, so we make the decisions based on the data coming out from the data warehouse. And then we talk to OpenStack using public APIs only. Recall, we don't make any changes inside OpenStack. We talk to OpenStack, but we don't change OpenStack. Does that answer the question?
Yes, it does. Yeah, thank you, Kenneth. Now, Kenneth, just to jump straight on to the next question, as they're sort of pouring in. Radoslav is asking, could you give us a bit of an insight as to how FishDirector differs from systems such as Yarn and Mesos? So just to repeat.
Sure.
Yeah, you've heard the question. Fine.
Okay. Here, what we're doing is we're managing the infrastructure. So from an infrastructure operator standpoint, we're providing an operating environment for the other applications. So whether your applications end up to be, say, certain Hadoop type of jobs, or you're running some web farms, that's completely transparent to us. That's contained inside the VMs. And as far as we're concerned, we provide virtualized hardware. Okay. As for the management of resources, there are some similar sorts of ideas, but our focus is to drive high utilization across the facility in an application independent manner.
Okay, thank you, Kenneth. Now, just to move straight on to the next question, this is more of an open question, I guess, open for debate. One of our audience is asking, high utilization, obviously, healthy and perfect, but at the same time, with the current trend of underutilization, people at least have that kind of buffer to protect them from reaching the limits of that utilization. Obviously, we can say that's a very expensive buffer to have. I guess the question is which is costlier, underutilizing or utilizing sort of very close to the limit, and how does FishDirector sort of cater for those peaks, when utilization is already high and then, further sort of resources needed?
Okay, so you engineer your facility to whatever peak levels that you want. So whether you want to use a workload multiple of 2, 3, whatever that multiple may be. Now, the bigger question is, once you have put in such a facility, what do you do in your downtimes, in the times when you're not maxing that amount of resources? In that situation, what we would do is to consolidate the workload onto as few physicals as possible, while still meeting the performance requirements. And then as your application, which is contained inside the VMs, starts to draw on more resources, it then triggers another rebalancing across the facility, and then we pack again we pack the VMs again to best fit that requirement across the facility. So to take that question a few steps further, I guess what do you do when there is a spike in resource consumption? It then depends on how long the spike lasts for. We would rebalance across the entire facility to meet the higher resource requirements. But certainly it could happen that the spike is lasting a much shorter period than your rebalancing cycle.
Thank you, Kenneth. Now, just to move straight on to the next question, because we have them sort of coming in at a faster pace than we're answering them. Here's a very specific query. How do you integrate with Red Hat, OpenStack, or SUSE Cloud?
Okay, that's quite straightforward. Now, first off, because we're not making any changes to OpenStack, every single part of what we do, it's outside OpenStack. Where we can't do that, we would provide a 100% API compliant component, which then on the OpenStack side would just be a simple configuration to point to our component as opposed to the standard component. And then because we sit entirely outside OpenStack, integration with whether it's Red Hat OpenStack or SUSE Cloud or any other OpenStack distributions, so long as it is a public API compliant distribution, that integration is simple, it's straightforward, there's no complexity to it.
Thank you, Kenneth. Now, just to jump on to the next question straight away, and again, to apologize to our audience, we can probably accommodate no more than 2-3 questions from this point on, in line with the time available. So here's a very concrete query. How do you gather your server states data?
Okay, so server states data, on the individual host, we deploy collectd. Alongside collectd, we deploy certain plugins to collect the metrics of interest. The metrics of interest would typically tell us what the resource consumption of the VMs, what the VMs are doing on each of the hosts from a resource consumption standpoint. And that data is then fed in to collectd, again using another plugin for streaming data. That plugin will take the data, stream it into a time series database. The time series database is then backed by a NoSQL database. It's Cassandra. Now, there are some interesting aspects here. As some of you probably know, collectd implementing plugins to collect D is very, very simple. And so if you want to build on our implementation to collect whatever metrics that could be of interest to you, it's very easy. One of the drivers for us when we select what building blocks we may use to build our solution is that we aim for zero training in a facility. So whatever a typical sysadmin may have in his toolbox, that's what we aim to use, which drives the decision behind collect D.
Thank you, Kenneth. Now, because the time seems to be running out on us, it'll probably have to be the last two questions. But here's a really interesting one. One of our audience is asking, basically saying, I understand that the computations for optimal packing is possibly very complex. And the question is, would it be possible to configure the rebalancing frequency to fit their particular data center?
Sure. So now, the short answer is yes, we can configure the rebalancing frequency to fit, and the rebalancing frequency would then have to take into account the size of the facility and how quickly we can power servers back on. Note that we power servers off to reduce energy consumption. And it also affects the lead time for us to migrate VMs across the facility. Now, for other audiences on the line here, the problem of packing, how is it complex? Now, for those of you who have kids, you probably observed that children, sometimes with the same number of toys, the toys may fit into the toy boxes at certain points in time, and at other points in time, the same toys may not fit. It's all about how you pack, what you put in, at which point, and where. And that, mathematically, that packing problem is a non-trivial problem, especially when you start considering that each variable that one needs to take into account becomes equivalent to a dimension. So you have a very high dimensional jigsaw puzzle problem to solve.
Okay, thank you, Kenneth. Now, I'd just like to apologize again to everyone whose questions will not be answered, but there's only room and time for a single question which we have remaining. And the question, Kenneth, is what do you use for your own data warehouse?
So the data warehouse part, we built on Cassandra. For sites that prefer, say, for example, HBase, building on Hadoop, we can do that as well. We have that option. And then layering on top of this underlying NoSQL database, we have a time series database so as to be able to have a time associated aspect to each of the metrics that we collect.
Kenneth, thank you for that, and I think that's all the questions that we can accommodate in the time remaining. So I'd like to thank you for a very inspiring talk on the server utilization crisis. Many thanks to all of you in the audience who have joined us for the webinar as well. Please join us again for our next monthly webinar, and just to say that following today we will be sending you a short survey to make sure we capture your feedback from today's webinar. Please also note that the recording of today's webinar and the presentation that we used today will also be available for you to collect on our Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you all once again, and we'll look forward to seeing you on our next webinar.